Kristen Ashison here, and we're still talking about the light and the eyes. Now we're going to focus on the eyes. So here is the human visual system. You can see we have how the eyes are connected into the back of the brain, and we'll talk about more about those brain connections in chapter 3. For chapter 2, we're really just focusing on the eyes. You see that nice little dividing line between chapter 2 and chapter 3. We'll tell you how the information gets out of the eyes, and that's kind of where we stop. And we'll pick up the rest in chapter 3. So we're going to be talking about, we talked a little bit about the optic array. That's part of what you can see in your visual field. So when you see here this right and left, that is contributing, this visual field is contributing to your optic array. So your field of view, because our eyes are in the front of our head, we can really see very well in front of us. This is really important for depth perception. Because we have binocular vision, we have both of our eyes, it gives us really good information about depth. It can help us see where we're going, and it can really help guide all of these fine motor skills that we have with our fingers and our hands. And so, again, for us, this is really, really helpful because of what we have evolved to do and what we, and kind of our evolutionary needs. Other animals have their eyes placed differently, such as this crocodile here. Because his eyes are on the side of his head, he can see almost entirely behind him and almost entirely below him. This is really good for finding food, finding something to eat. Most predators actually have their eyes on the front of their face, but because crocodiles are actually not trying to long-term pursue their prey, their ambush, they're needing more quick responses. And so their eyes having this bigger range of vision is really important. You'll also see a lot of times that prey, who also need a big field of vision, tend to have their eyes on their side of their head as well. Okay, so let's get into some anatomy. And again, this is a psychology class, so we're gonna kind of skim the top as best we can. So acuity and eye movements is where we're able to use fine detail for us to figure out that subtle manipulation, those subtle changes of the environment. So our eye movements are really, really helpful in allowing us to focus on things, being able to see fine detail. Again, that binocular vision using both of our eyes really allows us to have really good information about depth perception. And one of the things that we know about visual perception is it's actually one of the last developing senses because there's not a lot to look at when you're in the womb. Vision doesn't really start developing. The eyes are developed, but vision doesn't really start developing as a sense until birth. I mean, we have some light. There's some light that can pass through, but for all the other information about depth and those sorts of things are developing much later. The same is true. So this is one of the ones that's least developed at birth. We actually have 3 sets of muscles that help us move our eyes very precisely. And so we're not going to really go into the different kinds of muscles, but it allows us to have this precision that allows us to really control our eyes once we get a good handle on them. So there's a cute video. I really liked it. It's called From Crash Course on the anatomy of the human eye. So I'm going to let you guys watch that to go through the anatomy. It also is really good, and it starts to talk about some of the photoreceptors and that sort of thing. Because this is not an anatomy class, I thought that their nice job kind of glossing over it is the best way to do it. So please watch that video. You can pause this and go watch that video and come back. It's both linked on Canvas and on our YouTube playlist. So, moving on. Things I will talk about are iris and our pupil. These are the parts of the eye that you're most familiar with already. I remember being a kid when I figured out that your iris contracts, and you can see, and your pupil gets bigger when it dilates and all that good stuff. And playing in the bathroom and turning off the light and turning on the light and watching what my eye was doing. So again, in bright light, again, I'm sure you all know this, the iris contracts, and that makes that pupil smaller. Okay, so the brighter the light, the smaller that pupil, the less light you're going to let in to the eye. In medium light, the iris contracts less and the pupil starts to get bigger. In really dim light, that pupil is going to be really big. It's going to that iris is going to open up be fully relaxed, and the pupil is going to open up as much as it can. Any of you who have gone to the eye doctor, they can artificially do this too. Really open up that pupil's fully dilated so that they can see into the back of your eye, so that they can check the health of the eye itself. But typically this is happening in dim light. So if you haven't done it in a while and just want for nostalgia, go play in the bathroom with the light on and off and watch your iris contract and your pupil dilate. Pretty good stuff. Okay, so the lens is what we're going to talk more about, and I'm sure you're familiar with it as well, but we're going to kind of get into a little bit more depth. Okay, so the power of a lens, and you can think of a lens in your eye, a lens in the camera, is really about refracting that light and how far away the thing is you're looking at. Okay, so a weak lens doesn't refract much light. And it's typically pretty thin and flat, and you can see pretty far away. Okay, so that's when you're seeing pretty far away. The lens is going to be thin and flat, and again, we can look at things that are further away. Strong lenses refract light really sharply. This is when they get thick and they're rounded, and this is when we're going to be looking at things shorter distance. Again, there's really great launchpad activity that will walk you through this as well, so you can kind of get to play with both the lens of the eye and the lens of a camera and how this focal length changes the shape of the lens. So again, as the object moves closer to the lens, what we're going to see is we're going to see a change. The muscles in the eye are going to change so that that lens can change shape accordingly. So here are the pictures of the things I was just talking about. So again, when we have those thinner, more flattened lens, our lens is relaxed. Okay, our ciliary muscle is relaxed, and so our lens is relaxed. We can see it's flatter, it's thinner, and we can see far. Okay, so flat, far. When that object is closer, that ciliary muscle is going to contract. It's going to get tighter. You can think of that ciliary muscle as kind of like a rubber band around it. So when it's going to get tighter, it's going to get wound tighter, and that thing inside is going to get smaller. That lens is going to get thicker. It's going to become more rounded. And then we're looking at something closer. There's a nice mnemonic that we can use to kind of remember this. That ciliary muscle, remember, that's that rubber band around that lens. When it's flaccid and relaxed, we can see far, and our lens is shaped as flattened. So you see all those F's? Flaccid, far, flattened. Where is when we're looking at something close, that ciliary muscle, that rubber band is contracted, and that makes that lens more circular, more chunky, more rounded. Those C's for closer. So that's a good way to remember kind of that difference. But again, there is a launchpad activity that will walk you through this as well. The retina is really where all the magic's happening in terms of vision. This is where the image that we're looking at, whatever you're looking at, gets transformed. This is where our sensory receptors are. And it's being converted into a neural signal so we can get it into those neurons so we can get it into the brain. So this is where our sensory receptors are in our eye, is in the retina. And the changes in the lens are so that we can do a better job of getting that image to the retina, that we can focus better and get that image to the retina. So again, these light rays are reflected in different directions, and as that lens shape changes, that's going to change the way that those lights are reflected on the retina. Okay, so that's the end of our show for the eye. The next video we're going to talk about, we're going to really go into a lot more depth on this retina, and we're going to really talk about how, about those sensory receptors. Thanks.